and we're going to have a -1 value, we're going to have a minimum, and we're going to have a 5 value. So I want to get all three of those to see what, this is going to be my absolute min, and this will probably be my absolute max. But we'll see after we actually graph it. So we're going to hit y equals, and I'm given no window, given no graph. So I'm going to do my best. X squared minus 6x minus 1. I'm going to graph it. It fits nicely in my picture. Maybe not over 5, it goes over to 10. Let me see what the window is. I only go over to 6, so I'm going to go over to maybe 10 to get that right side of the graph in my picture a little bit better. So I have a -1x value, a 5x value, and this value in between, the vertex. So I'm going to find all three of those. So I'm going to find my -1 value, I'm going to find my 5 value, and I want to find my vertex values. So I'm going to go right to window. I'm sorry, I'm going to go right to second calc value. I want to see what my -1 value is. And that's going to be 6. So this coordinate here is going to be -1, 6. Then I'm going to quickly get that by just typing in 5. I don't have to go through the process again. I just hit 5, and it gives me the x value 5. And that's going to be at -6, 5, -6. Notice, it isn't way up there. It's actually down here. It's actually down here. My graph, my interpretation was incorrect. So it's going to be at 5, -6. Now I need to find the minimum value. So I'm going to hit second calc. I'm going to find the minimum value. I have to left bound it. I have to right bound it. And that's going to be at 3, -10. 3, -10. And let's recall that this was a misinterpretation. The graph, the calculator shows us accurately what the choices should be. So the absolute maximum value is going to be the highest y value is 6. So the absolute maximum value is 6 at x equals -1. The absolute minimum value is not going to be the -6. It's actually going to be the -10 at x equals 3. Same type of question now for an x cubed. So let's type it in, and it's from 0 to 10 this time. So I'm going to type that in, y equals just like it looks. Clear that out. X cubed minus 6x squared. And that's it. X cubed minus 6x squared. I'm going to graph it. And notice I don't have everything I need in my drawing. So I'm going to zoom out a little bit through the window. So -6 is good, but I want to take that further to the right other than 10. So I'm going to take that to the right about 22. And my min, I really need to go down lower one. So -44. And let's graph that. I want to get all those curves. So I'm going to look for my value at 0. I'm going to look for my value at 10. And it's really nice to draw a pencil version of this to see where they are. Okay? So I'm going to throw in 0 and 10 through value. So I'm going to go to second calc value. And I'm going to type in my 0. X equals 0. And notice it's right at that maximum. It's right at that local max. So that's going to be 0, 0. Now I want to get the value at 10, which would be over here somewhere. So all I have to do is type in 10 while I'm still in this value mode. So I just type in 10. And it gives me 400. It's not even on my screen. So way up here, this endpoint is going to be 10, 400. Obviously my absolute max. Now I want to find out what this minimum value is here at that little valley. So we're going to hit second calc min. See where I'm located. I can't find it. Where's my cursor? Notice it says it's at 8. So this is way over here. So I'm going to try to get it in until it comes into the screen. There it is. So I have to get it to the left of my drawing. So there's my left bound. I'm going to do my right bound now. So it's going to be at 4, -32. At that little low spot. That's going to be 4, -32. Now I'm going to take that information and fill it in. Absolute maximum is 400 at x equals 10. The absolute minimum value is -32 at x equals 4. Now, number 18, notice, it's an x squared, but now it says from -infinity to infinity. That's a little different. So we're going to do y equals, we're going to type this in to x squared minus 24x plus 150. Now that's going to be really hard to see in the screen. Let's see if it even shows up when I graph it. And this means it was thinking. You notice it's not even in my graph. So I'm going to do this thing called zoom fit. Zoom, and I'm going to scroll until I see the word fit. So zoom fit. And let's see what that does to our drawing. Notice it's in our screen now, at least. And that's going to give me a minimum. So I want to know what the absolute minimum is. And the absolute maximum. There is no max. So the absolute minimum, we'll find that second calc. We'll find our min. I'm going to left bound. I'm going to right bound. Let's see what that is. So it looks like it's going to be 5.99. 78 or 6, 78 is going to be our absolute min. So 6, 78. So the absolute minimum is 78 at x equals 6. Cost function. So find the total profit function, and let's recall that profit is equal to the revenue minus the cost. So the revenue is this, and the cost is that. So our profit function is going to be -1/2 x squared. -1/2 x squared. And then I have to do 800 minus 100, that would give me 700x, and then I have to just subtract the 4900. And that is my profit function. And we would type that in. Negative 1/2 x squared plus, and don't forget it's 800 minus 100, 700x, minus 4,900. The profit is maximized for the production of how many units? So again, we can go to our calculator, and we're going to type this in and see what the maximum value is. So y equals, I'm going to type in the profit function, so that's where the profit is maximized. So negative 0.5 x squared plus 700x minus 4,900. I'm going to graph it. I'm actually going to zoom fit it. Seems like it might be a big graph. So I'm going to go down to zoom fit and see if that brings in everything I need. So it's negative x squared, and that should look something like this. And notice we have it on the upswing here, so we need it on the downswing. Now I'm just going to hit zoom out. Hit zoom. I'm going to zoom out once or twice to see if I can get that actual maximum value in the picture. Didn't work there, so I'm going to hit zoom out again. Just hit enter twice. It starts to zoom out. I'm going to hit enter again. I'm going to zoom out again. Every time I hit enter, it will zoom out. And I think I found my max. I'm going to zoom out one more time, and you'll get that nice parabolic shape. And I'm going to look for that maximum value there. So I'm going to hit second, calc, max, and the left bound, and then I'm going to right bound. And looks to be 700 units will produce a profit of $240,100. So I'm looking at the 700 as the amount of units that I'll be selling. So the profit is maximized at the X value, 700 units. This is an actual calculus problem where we're going to have to solve. So they want me to maximize this portion. They want me to maximize the Q equals portion of it. So I have Q equals 6x y squared. But notice over here, if I solve this for y squared equals 10 minus x. I can plug in 10 minus x for y squared. So Q equals 6x times whatever y squared is. And notice y squared is 10 minus x. So I'm going to graph this. I'm going to actually graph this as y equals 60x minus 6x squared. Y equals, clear it out, 60x minus 6x squared. I'm going to zoom fit. Actually, I'll zoom standard. This one doesn't look too drastic. So I'll scroll down to zoom standard and see if that doesn't give me my, no, it doesn't give me my graph. It looks like it went up and then came down. So I'm going to do a zoom fit. And I'll find that maximum value. The x maximum value will actually maximize this graph. So I'm going to look for the x value for the vertex. So I'm going to hit second, calc, maximum. I'm going to left bound it right towards the tip of that vertex. Then I'm going to right bound it. And it looks to be 5, 150. Now this is tricky because the x value that maximizes this is 5. Okay? So that will be this answer. Now I'm tempted to put the 150 in, but that's not what we're going to do. We're actually going to put the 5 into this equation over here. So it's going to be y squared equals 10 minus, and remember x equals 5. So 10 minus 5 is 5. So y squared equals 5. And the answer is going to be the square root of 5. So the y value is going to be the square root of 5. And notice it tells us to use radicals. So we have to be careful on number 20. So this one is kind of a basic calculus problem. These are called optimization. So you have a river, and then you're going to have a fence bordering the river, a little rectangular pen. And they give us the length of fence. So 1900 meters of fence wire is at my disposal. So this wire is going to be 1,900. I can go through a whole bunch of calculus, but there's a trick to this. What you want to do is you want to take half of 1,900. So I'm going to hit second, quit, and go to my normal calculator mode. I'm going to do 1,900 divided by 2, so 950. And when you do that, that's going to give me this length of the long side, 950. Now, these two sides add up to 950. So I take half of 950, which is going to be, I believe, 425. I divide that by 2. 475, sorry. So that's going to be 475 over here and 475 over here. Now notice, if we added this all up, we would get 1900. So the maximum area is going to be 475 times 950. So that's going to give me 451,250 meters squared. So 451,250. All I did was 475 times 950. And its area, so that's going to be meters squared. The length of the short side is 475 meters. The length of the long side is 950 meters. And notice when I do the area, m times m is m squared. So this spot here would be 475, and this spot here, the longer side, would be 950. They want me to find the maximum profit. And let's recall that profit, P of x, is equal to R of x minus the cost, C of x. So I have to do negative 0.5 x squared. And then this 50x minus 4x, which I believe is plus 46x. And then I have to subtract the 15. So that's my p of x. And now I'm going to graph that. It's a negative x squared, so it's going to look like this. And they want me to maximize the profit, so that would be the vertex. So let's type that in, y equals. I'm going to clear it out. I'm going to type in negative, not minus, negative 0.5 x squared. These numbers are a little large, but I'm going to do zoom standard to see if that gives me a nice graph. And no, it does not. So I'm going to do my zoom fit again. Zoom, and I'm going to scroll down until I see the word fit. Zoom fit, and it should get the maximum in my graph. If it doesn't, I'll just zoom out. So it doesn't, so I'm going to hit zoom, then I'm going to zoom out, and I hit enter again. Now if I want it to zoom out again, I just hit enter one more time. I don't even have to hit the zoom button. I just hit enter again. And it zooms back a little bit further, and notice I get my maximum, so I'm going to hit second calc maximum. I'm going to left bound it to the left of that maximum, then I'm going to right bound it to the right of that maximum, and it gives me 46 and 1043. So the x value is 46, and the y value is 1043. X value is the amount of units, and the y value is the profit. So that's going to be the dollars. So the dollar sign would have 1,043, and the x value would be 46. The profit function, it gives me this thing called the price function. So, and the price function, all the revenue function is the price function times x. So I basically have to take x and multiply it by 170 minus 0.75 x. So all I have to do is distribute the x to that. So that's going to give me 170 x minus 0.75 x squared. And that's my revenue function. Now, this is not a lowercase p. This is the actual profit function. And let's recall that profit is revenue minus cost. So I have my revenue function, and now I have to subtract the cost function from that. So I have to do negative 0.75 x squared minus 0.5 x squared. So I'm going to clear this out. I'm going to hit second quit to go to my normal computational screen, and I have to actually do the arithmetic of the revenue 170x minus 0.75 x squared minus the entire quantity of the profit, and the profit is, the cost, which is 4,500 plus 0.5 x squared. So notice I have to distribute that negative to the 4,500 and to the 0.5 x squared. So I'm going to have to do negative 0.75, negative 0.75 minus 0.5, and that's going to give me negative 1.25 x squared. Negative 1.25 x squared. 170 doesn't subtract anything. There are no other like terms, so it's going to be plus 170x, and then I have to subtract the 4,500, and that's the profit function. Now, how many suits must the company produce to sell in order to maximize the profit? So this is the negative x squared. It's going to look like this. So I have to find the x value to find out that number of suits. So I'm going to type that in. I'm going to actually type in the profit function. So y equals, clear it out, negative 1.25 x squared plus 170x minus 4,500. I'm going to graph it. And I left the old screen up, so it found the maximum. So I'm going to hit second calc to find the maximum. I'm going to left bound it. I'm going to right bound it. And I have to sell 68 units to make a profit of $1,280. So I have to sell 68 suits to make a profit of $1,280. And now it wants to know the price, not the profit, the price. So I have to take the 68 suits and put it into the price function. So my calculator key is going to be 170 from the price function minus 0.75 times 68. And that'll give me the price. I'm going to hit second quit to get to my calculators. So I'm going to type in 170 minus 0.75 times 68, and that's going to give me $119 per suit. The price per unit must be $119. Largest volume that can be mailed. So all I do is find out that the mailing limit 78 inches, the combined length and girth, that's the distance around the package. So all I do is I take that 78 and I divide it by 2. 78 divided by 2. It's going to give me 39. Now, that 39 is a magic number. I don't cut that in half because it's three-dimensional. I divide that by 3. And that's going to give me 13. So the dimensions are going to be 13 by 13, and I need to figure out what y is, and I believe that's going to be 26. You double it. So the dimensions of x are 13, and the dimensions of y would be, you double it, 26. And in this case, it would be inches. Not inches squared, just inches.